Hello everyone. In this video we're going to be solving a radical equation. The square root of 5 minus x is equal to 5 minus x squared. We're going to be solving for x here. Okay, at this point you can just go ahead and pause the video and then try the problem yourself first. Alright, so we could definitely solve this as a quadratic equation, replacing 5 with a or just treating as a number as you know in the other video. So, but we're going to use a different approach here. So let's go ahead and do that. I'm going to square both sides. That's going to get rid of the radical. So I'll be getting 5 minus x is equal to 5 minus x squared quantity squared. If I expand the right hand side, I'll be getting 25 minus 10x squared plus x to the fourth. Now I want to collect everything on the same side. So let's do that. X to the fourth minus 10x squared plus x plus 20 equal to 0. Now, one thing that's good about this equation is that there's no term with x cubed. As you know, or you may know, in the general formula for quartic equations, we actually turn the quartic into a cubic equation. And then the cubic can be solved because we have the Cardano's formulas. Again, you take advantage of the quadratic, so on and so forth. But anyway, you have to reduce the degree. So, but the first step we take is actually getting rid of the x cubed term, because without that, we can't really reduce the power. So, but this equation is already that way. So we don't have an x cubed, which is nice. And this is going to allow us to actually solve it in an easier way. And since we're looking for some solutions, hopefully we're going to be getting some nice results here. Okay. Now, how do we solve this quartic? And it doesn't have a cubic term. So how does that make it easier? Well, we're just going to assume that this can be factored into two quadratics. Okay, that's the plan. So let me go ahead and proceed with that. So what I'm going to do is I'm actually going to take this quartic and set it equal to the product of two quadratics, but I'm going to write them in a special way. So let's see how that goes. So the first factor is going to be x squared plus ax plus b. Now, since I don't have any term with x cubed, I'm going to be able to write the second factor as x squared minus ax plus c. Because when I multiply x squared by ax, I get ax cubed. And they're just going to cancel out. So not having the x cubed actually allows me to do this. And it's actually a really good thing to do, because from here I can actually find the values of a, b, and c. Let's see how that goes. So I'm going to use the distributive property. That's going to give me x to the fourth minus ax cubed plus cx squared. Let me distribute the whole thing. Plus ax cubed minus a squared x squared plus acx plus bx squared minus abx plus bc. You know, it's kind of messy at the beginning, but then it's going to simplify. Ax cubed cancels out. That's the whole point here. And then we're going to write this as x to the fourth. Plus, if you put together the terms with x squared, we have three of them. So I can write it as b plus c minus a squared. That's multiplied by x squared. And the coefficient of x is ac minus ab. So I can write it as ac minus ab multiplied by x. And then finally, we have the bc. Okay, cool. Now, this expression is supposed to equal x to the fourth minus 10x squared plus x plus 20. So from here, we get a bunch of equations. In other words, a system of equations, and now we're going to solve it. Well, I should say, is it always solvable? Well, we're going to be getting three variables and three equations, so we should be good to go. Okay, so what do we get? We get b plus c minus a squared is equal to negative 10. ac minus ab is equal to 1. And bc is equal to 20. Awesome. Now, how do we solve this equation? So we're going to be doing some manipulations here. I'm going to isolate b plus c. That's going to be a squared minus 10. From here, I can actually go ahead and take out the a and a times c minus b. So it's going to look like this if I do. And then I'm going to divide both sides by a. And that's going to give me c minus b being equal to 1 over a. Now, this is a good thing to have because we're going to use this to solve our system. How? Okay. Notice that in this system of two equations, we only have b and c on the left-hand side. And here, also we have B and C only, so nothing, no A in the third equation. That's good because from these two equations, we can actually solve for B and C in terms of A. Then we can go ahead and plug them here and find what we're looking for. So let's go ahead and add these equations up. If we do, we're going to get 2C, and then 2C is going to equal A squared plus 1 over A minus 10. Let me go ahead and, simplify this. And since I'm going to multiply, actually, it might be beneficial to leave it like this. So what I'm going to do is I'm actually just going to put a 1/2 in the front and write it like this. So it's going to look like this. So that's going to be the value of C. And in the same manner, I can actually find the value of B by subtracting those expressions. And then, of course, using the 1/2. And that should give me B equals A squared minus 1 over A minus 10. Awesome. So this is nice. And what we have here is B and C in terms of A. Now we know that B times C is equal to 20. So let's go ahead and do that. B times C is equal to. So we're going to multiply these two quantities. 1/2 times 1/2 is 1/4. And if I write the B as actually A squared minus 10 minus 1 over A, and the C as A squared minus 10 plus 1 over A, this kind of resembles difference of 2 squared, doesn't it? So, and then we know that BC is equal to 20. So this result actually equals 20. Okay? So let's go ahead and proceed from here. BC is going to equal, well, we can actually do the following. Multiply both sides by 4 and use the difference of 2 squares. That's going to give me A squared minus 10 squared minus 1 over A squared is equal to 4 times 20, which is equal to 80. Obviously, at this point, we just have to expand this and simplify the equation. A to the 4th minus 20A squared plus 100 minus 1 over A squared is equal to 80. Now we can just go ahead and multiply both sides by A squared. That's going to give me 8 to the 6th power minus 20 A to the 4th. Actually, I could bring this over here, and that's going to give me plus 20 and multiply by A squared. That's going to be 20A squared. And then we're going to be getting minus 1 equal to 0 here. Okay? Awesome. Now, you might be thinking like, this is a 6-degree equation. How am I going to solve it? Well, it's solvable. It's factorable. And it's beautiful. Okay, let's go ahead and do that. So I'm going to separate these two terms. And then the middle terms, the two ones in the middle, I can actually factor out a 20A squared. That's going to give me A squared minus 1. Awesome. Now from here we actually get, now as you know, this is like a difference of 2 cubes. If you think about A squared cubed minus 1, if you think of this as difference of 2 cubes, so I can just go ahead and factor it that way. That's going to give me A to the 4th plus A squared plus 1. And then minus, I have the A squared minus 1 again, which allows me to factor this because I have a common factor. So let's pull out the A squared minus 1. And then from here, I'll be getting A to the 4th minus 20A squared is going to give me negative 19A squared plus 1 is equal to 0. Awesome. Now from here, we're going to be getting some nice values. And of course, we're looking for integer values here. So I'm just going to consider this one for now. And obviously, the second equation is also solvable, by the way, because if you say, okay, A squared equals Y, and then this is a quadratic, you can use it with the quadratic formula. It has a positive discriminant, so on and so forth. So it's solvable, perfectly solvable. I'm going to focus on the integer solutions. A is either 1 or negative 1. Now, what do we know? We know that we can write B and C in terms of A, right? So B is equal to 1/2 multiplied by A squared, right? Minus 1 over A minus 10. And C is equal to pretty much the same thing, except there's a plus sign, okay? So C is going to be the same thing, except we have a plus sign in front of 1 over A, okay? So from here, by substitution, we're going to be able to find the appropriate value. So let's take A equals 1 first. If I plug in 1 here, that's going to be 1 minus 1, which is equal to 0. Then I'll be getting B equals negative 5. Awesome. And in the second one, I'll be getting, I can just use the implication here. If A equals 1, then C is also going to be negative 5. Right? No, actually not that. 1 plus 1 is 2. 2 minus 10 is negative 8. That's going to be negative 4. Okay, cool. If a equals negative 1, what happens? Let's take a look. If a equals negative 1, then I get negative 1 squared, which is 1 plus 1, which is 2. And then I get b equals negative 4. And then if a equals negative 1, I get 1 minus 1 here, which is 0. And then I get c equals negative 5. So basically, b and c are interchangeable, as you can see here. And if you go back to where we factor the original expression, you're going to notice that actually the values of b and c don't really matter, because you're still going to get the same thing since a repeats in both of the equations. But anyways, what matters here is that we were able to express our write our expression as x squared plus ax minus ax. Remember that? So I'm just going to write it as plus x, and then you can use minus 4. And then the other one is just going to be x squared minus x minus 5. Okay? Since one of them is going to be negative 4, the other one is negative 5, so it doesn't really matter which one is which. Okay? So if you go ahead and distribute this, you're actually going to see that we get the original problem, okay? Which was our x to the 4th minus 10x squared plus x plus 20. Anyways, so we're going to go ahead and solve this equation, but this one is fairly easy to solve. We're going to set it equal to 0, and from here, we're going to use the quadratic formula. Let's go ahead and do that. Negative b plus minus the square root of b squared minus 4ac. That's going to be 1 plus 16, as you know, divided by 2. So that's going to give you negative 1 plus minus the square root of 17 over 2. And then from the second equation, we'll get 1 plus minus the square root of b squared minus 4ac. That's going to give you a 20, right? Divided by 2. And this should give you 1 plus minus the square root of 21 over 2. Awesome. But are these all solutions legitimate, right? That's another question we need to ask. Well, we're going to go back to the original problem where we actually squared both sides, because in order for these equations to work, we have to check with the original radical, which was the square root of 5 minus x is equal to 5 minus x squared. Okay, so let's go ahead and check whether our solutions are going to work there. 5 minus x is equal to 5 minus x squared. Obviously, substituting these values into the equation is not going to be very feasible, right? So what we're going to do is we're actually going to use the domain here. So 5 minus x needs to be greater or equal to 0, which means x needs to be less than or equal to 5. And we also know that 5 minus x squared needs to be greater or equal to 0, which means x needs to be between negative root 5 and positive root 5. Okay? Obviously, this is going to be met if we have this. We have to take the intersection. Both of them have to be true. So this is our domain. Okay? So obviously, any value that is not in that boundary, we're not going to accept. And square root of 5 is just going to be, if you think about it, it's going to be about 2.2-ish maybe. Negative 2.2-ish, negative 2.3-ish. Okay, so let's go ahead and check these out. If we take the negative root 17 here, that's about 4. We're going to get negative 5 divided by 2, which is not going to be valid. But what about this one? What about this one? This one is going to be fine because it's definitely going to fall in that interval. So one of the solutions is going to be this one. What about the square root of 21? Well, if we take the square root of 21 to be somewhere between 4 and 5, let's say 4.5 is probably a little too large, but let's say 4.4. That's going to be 1 plus 4.4 is going to be 5.4, and then 2.7 again is going to be too large, because if you square it, you're going to get 7.29. So again, we can't take the positive here. We have to take the negative version here. All right. So those are going to be the solutions of our equation. Thank you for watching. Please comment, like, and subscribe. I hope you enjoyed the video, and see you in the next one. Take care. Bye-bye.